Okay, so we are back with more organic chemistry. This is Chem4, week 10, video number 2. So we are now in the process of talking about alkanes. Alkanes is the first of 14 functional groups. So shapes of organic molecules, as long as any two structures show identical connections. So as long as two structures show identical connections between atoms, they represent identical compounds. All right. Sometimes this is easy to see. Sometimes this is kind of difficult to see. So we're going to do some examples that look like, geez, is this the same compound or not? And really, you kind of have to use your pencil or your finger and just kind of run things around and see if you end up with the same structure or if you'd actually break stuff and rearrange it. So let's have a look. First of all, let's reread. As long as any two structures show identical connections between atoms, they represent identical compounds, no matter how the structures are drawn. Why is that? Because free rotation takes place around carbon-carbon single bonds. Carbon-carbon single bonds can rotate like this, and then they can swing and maneuver, so it's very flexible. When you get double bonds, then things kind of get locked into place. Let's take a look at these two in this example. Are these the same or not? Well, in the first one, I see an OH group, and the second one I see an OH group. Now, basically, I've just taken the first one. Look at my fingers. So I've taken the first one, and I'm literally just kind of flipping it. See how I'm doing that? I'm flipping it. I'm not breaking any bonds. I'm just moving the entire molecule. These are not isomers. These are identical. Okay? One was just flip-flopped like that. All right? I didn't have to break any bonds or anything. I just had to pick the whole thing up and twist it. All right, let's try another one. Example. Which of the following, I'm going to draw some structures. Which of these are identical and which aren't? All right, so the first one, A. Let me get through the drawing here and get my hand out of the way. But I've got CH3 three times, and I got a bunch of CH2s. In the second one, B, I've got some CH3s and a bunch of CH2s. And in the C, I got CH3 on the end caps, CH2s. I do see a CH also. So let's have, if you have a close look here, the one in B we have a carbon that has 4 carbons attached. You see the one in B that has a C and then 4 carbons attached? A and C are the same molecule. Why? Because the far left CH3 vertical on A, I can actually take that and stretch it out like this, pull it tight. All right, so on your own at home, see if you can draw the 5 isomers of C6H14. Try it and make sure you don't repeat them. Okay, there's 5 isomers for C6H14. See if you can draw that. All right, so now I want to talk about how do we name alkanes. Okay, first I'm going to talk about some of the branches before I get into the rules. There's a set of rules you have to practice and practice and practice until it makes sense. So some background first before I get into the rules. Naming alkanes. Well, a chemical name has 3 parts. It's got the parent in the middle and then the prefix. And sometimes it has a suffix. For most of our stuff, the parent will be the end. All right, but straight chain alkanes, they're named by counting the number of carbons and adding ANE as an ending. Okay, these are all, alkanes are carbon-carbon single bonds, right? So we name them some sort of ane ending. CH4, simple as it gets, 1 carbon, methane. Ethane is 2 carbons, CH3CH3 or C2H6. Next one, CH3CH2CH3, propane, 3 carbons. Fourth one is C4, that would be CH3CH2CH2CH3. You can get the idea of why I'm writing C4, C5. C5 will be CH3, CH2, 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 CH3. But these guys are all C2H6, C3H8, C4H10, C5H12. There's a general formula going on here. Okay, C5 pentane, C6 hexane, heptane, octane, nonane, decane. You want to learn those 10 words: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. You want to learn those because the alkenes and the alkynes and everything else is based on those names, right? Then there is a general formula, CnH2n plus 2, represents alkanes. Now those were straight chain. Alkanes that have branches, all right? Well, substituents or branches, substituents is just another word for branches. Branches such as a CH3 group or a CH2CH3 group that branch off of the main chain or the parent chain, these two have special names, and they're very similar to the parent compounds you see above me. So they're not freestanding alkanes, they're branches. So they're called alkyl groups. So a CH3 branch is called methyl group. A CH2CH3 branch is called an ethyl group. A CH2CH2CH3 group is called a propyl group. And then we have a special propyl group where the attachment's at the middle carbon. That's called isopropyl group. So you want to know those four. Those are the four branches we need to know for this class. All right, before I get to the rules for naming, I have one more thing to talk about, and that's the types of carbon atoms. Carbon atoms can be primary, secondary, tertiary, or quaternary. So what the heck does this mean? First of all, the R just means any giant or small carbon remainder of the molecule. So R is like remainder of the molecule. So if I have a little CH3 end right there, that carbon is attached to only one other carbon, so it's a primary carbon. In my second example, the carbon with the C is attached to two R groups. Those are carbon-based. So that carbon that I've drawn with the C is attached to two other carbons. That makes that carbon that I've drawn there a secondary carbon. Well, if I have three R groups attached and only one H, this is going to be not a primary or a secondary carbon, but a tertiary carbon. Tertiary means that that carbon I'm pointing at in the middle is attached to three other carbons. All right. Now, in some circumstances, we have all four R groups around it, and this would be a quaternary carbon, and that is not as common, but I thought I'd put it in there for you as well. All right. So that is all we have for kind of getting us set up for naming alkanes. Now let's go over the rules for naming alkanes with examples. Practice makes perfect on this, not just watching the video and listening to me and watching my notes, but writing out all these notes is the best way to learn this, and of course the homework problems. So now the naming rules. Number one, you want to name the main chain. This is the longest continuous chain. It's not necessarily the chain that's written straight across your piece of paper, by the way. You could have a long chain that goes like a snake. As long as your finger can go all the way along it uninterrupted, it's the longest chain. Now, the first example I'm going to do, of course, is going to have the longest chain be left to right. If I count those carbons left to right there across, it was heptane, 7 carbons. Number two, the second rule is to number the main chain carbons. Now, how do you number the main chain carbons? Because you got two ends. Which end do you name it from? Where do you start the one? So it says, start at the end where the branch is the closest. So I'm rewriting out this molecule again. We've established it's some sort of, quote, heptane. All right, well, I see that I have a branch really close on the left-hand side, not so close on the right-hand side. So I number 1, 2, 3, 4, 5, 6, 7 left to right. All right, so I got my numbering down. Rule number 3, identify the branches and number them according to whatever carbons they're branching off of. Well, these are both little CH3 groups. You see them popping up, the verticals. Those are CH3 on carbon 2, CH3 on carbon 5. All right, so I'm going to rewrite it, and I am going to identify each of these as methyl groups. A CH3 group is a methyl group. The far right one is a 5-methyl, 5-methyl, and the second one is that should say 2-methyl. I've made a mistake there. That's 2-methyl, not 3-methyl. Number 4, hopefully I fix that later. Write the name as a single word. So this should say 2,5-dimethylheptane, not 3,5. I've made a mistake. That carbon on the far left that I've circled, that CH3 bubble, is on carbon 2, not 3. That should be 2,5-dimethylheptane. Okay, next example. Write names for the following structures. So I'm going to give us some structures and we have to write the names. All right, so where is the longest chain? It's not going to be straight across horizontally. I'm going to, let's see, I'm circling the longest chain. Do you see how that's done? That is the longest uninterrupted chain. Number it accordingly with the branches having the smallest branch numbers. CH3 is on carbon 2. The snake that I circled, by the way, is 8 carbons long. 8 carbons is some sort of octane. So I've got a 6-methyl branch. I've got a 2-methyl branch. So I call it 2,6-dimethyl octane. 2,6-dimethyl octane, one word. B, all right, find the longest continuous chain. I've done so and I circled it, I bubbled it. I number it where I keep the branches to the smallest branch number. Numbering from the right keeps the branches the lowest. And I see it's a heptane, and these are ethyl groups. ETHYL. And they're both on carbon 3. So it's 3,3-diethylheptane. 3,3-diethylheptane. All right. Yet another example for practice. Draw a structure of the organic molecule given its name. Now it's the other way around. I actually like doing this way better because I'll take the parent. I'll take the backbone. In A, I'll take the hexane to start with, and I'll just draw it out. In B, I'll start with the octane, draw it out, and then make my attachments, and then fill in my H's. For C, what I'm going to do is I'm going to draw the parent, which is the pentane. So see how I draw out my hexane for A? And then I just say, oh, 3-methyl, boom, pop it on there like that. Really bare bones. But to get the answer right, and you can see I'm going to put a box around the proper answer, I've got to put all the H's on those carbons. For B, I see the octane. Boom, 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 boom. I draw out 8 carbons, 3, 4, and I put my methyl group on 3, methyl group on 4. Now that's the very bare bones. I've got to start attaching my H's everywhere, and I've done so, and I'm going to put a box around my answer. You can take an initial step before that and just do your dink, 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 dink with all your H's, and then put your H's in your final answer if you'd like. Pentane for C, draw the backbone. 2, 2, 4. Gosh, 2, 2, 4. There's a lot of little methyl branches here. 3 branches. If you want, you could dink all your H's around there on the bare bone structure and then slide it over into your final answer. You cannot put a box around anything except the ones I've put here, okay? The other ones are way too bare bones. All right, those are just leapfrog from those to the right answer. All right? Okay, so there is the first 2 videos for week 10. All right, so the next video we're going to cover cycloalkanes, alkenes, alkynes, and then we might get into aromatic compounds. We're still working our way through chapter 11, so let's go ahead and watch video number 3 coming up right after this. All right.